Hello everyone, welcome to the channel. In today's video, we are diving deep into one of the most powerful services in the Azure ecosystem, Azure Function. This will be a complete tutorial going from basic to advanced, designed for intermediate to advanced developers who want to build scalable event-driven serverless application on Azure. Okay, so let's start. So, what exactly is an Azure Function? An Azure Function is a serverless compute service provided by Microsoft Azure. It allows you to run small piece of code called functions without having to manage infrastructure. You simply write your code, define a trigger like an HTTP request or a message in queue, and Azure takes care of the rest. It follows a pay-per-use model, meaning you are only billed for the time your code runs. This makes it highly cost-effective for workloads with unpredictable or fast traffics. Now let's understand what does serverless mean. It means you don't have to worry about managing or provisioning any servers or infrastructure. Instead, you just focus on writing your code, and the cloud platform automatically handles everything needed to run it, like scaling, maintenance, and availability. Now let's look at few of the advantages of the Azure Serverless Functions. First up, Azure Functions are serverless. This means you don't have to manage any servers or infrastructure. Then next is cost efficiency. The pricing model is super cost effective. You only pay when your code runs. So if your function isn't being used, you're not paying anything. This makes perfect for projects with variable workloads or infrequent triggers. Azure Functions automatically scales up or down depending on demand. Got a sudden spike in users? No worries. Your functions will scale seamlessly without you lifting a finger. That is automatic scaling for you. Event-driven triggers is one of the advantages of the Azure Functions. One of the coolest thing is that the function can be triggered by all kind of events like HTTP requests, messages from queues, timer schedules, and more. This event-driven model makes Azure Functions super flexible. Multi-language support is also present in Azure Functions. Whether you are a fan of C#, JavaScript, Python, or even PowerShell, Azure Functions has covered you. It supports multiple languages, so your team can use what they know best. Azure Functions integrate deeply with other Azure services, be it a Cosmos DB, Event Grid, Service Bus, Logic App, making it simple to build and powerful workflow and applications. You can develop and deploy your functions quickly using tools like Visual Studio, Code, or other Azure portals. Plus, you can hook them up with CI/CD pipelines to automate deployments, speeding up your time to market. This is rapid development and deployment. Because they are lightweight and independent, Azure Functions are great building blocks for microservices. This lets you break your app into smaller, manageable pieces that are easier to develop and scale. Also, it comes with security, which is backed by Azure. Azure Functions benefit from Azure enterprise level security, including identity management, encryption, and compliance, so your apps are safe and sound. It offers flexible hosting options, whether you want a fully serverless consumption plan or need premium performance with VNet integration. Azure Functions offers different hosting plans to fit your needs. We'll be looking all of the hosting plans and their advantages as well as disadvantages. And if you want to develop and test your function locally before deploying, Azure Functions core tools make that super easy. Lastly, Azure Functions can connect to lots of external systems to custom bindings, making your solution even more flexible. Now let's talk about when and why use Azure Functions. Azure Functions are great for scenarios where you need to execute small unit of work in response to event. Think about use cases like processing files, upload to a storage container, running background jobs on timer trigger, handling messages for a service bus queue, responding to HTTP API calls. Essentially, if it is event driven and doesn't require a full-blown web app or service, Azure Function might be a best bet. Let's now talk about hosting plans, how Azure Functions run under the hood, and how you are built for them. First is consumption plans, which is a default serverless option. The consumption plan is the default and most popular hosting plan. It gives you true serverless behavior. That means your functions scale up automatically based on load, and you only pay when your function is running. It has auto scales, no need for managed infrastructure, best for small to medium workloads with variable traffics, pay only for actual execution and duration. Use it when you want the cheapest and simplest option for event-driven workloads. The Flex Consumption Plan is an enhanced version of regular consumption plan. It gives you faster startup times, support for virtual networking, and the ability to have always ready instances to reduce cold start. Better control with the concurrency for instances. It scales automatically and it still is a pay as you go with more performance. You can use it when you want low cost scaling plus better performance and networking control. The premium plan is for production grade workloads that needs more power, zero delay and more flexibility. It offers no cold start. It has a pre-warmed instances, higher CPU memory and execution time. Can run continuously, full VNet integration, support custom Linux containers. It can be used when your app is always running, needs high performance, or you want control over resources. Now let's look at dedicated plan. Your function runs just like web apps in app services. It's not serverless. You run on reserved infrastructure, so you are built regardless of usage. It's ideal for apps with constant traffic, uses existing app service plan, full control over scaling and pricing, great when you already have a spare capacity. It supports ASC, app service environment, for isolation and security. We can have a couple of app service plan, be it standard or premium. Now the last one is Azure Container Apps. Azure Function also runs inside Azure Container Apps, a fully managed platform for container-based apps. This gives you modern microservice support with the functions programming model. It can package custom libraries and run complex apps, deploy alongside other microservices or APIs, use GPU-powered compute, and no Kubernetes management overhead. Use it when you are building cloud-native solutions or migration from legacy systems to containers. Now let's understand what are triggers and bindings in Azure Functions. A trigger defines how function is invoked. Every Azure function must have exactly one trigger, and it determines the function execution start point, like an HTTP request, a message on queue, a file change in blob storage, or a timer trigger. Bindings are a way to declaratively connect to input or output data from external sources without having to write boilerplate code. Azure Functions support both input bindings to read data and output bindings to write data. You can see in the image, here we have a HTTP trigger based function which is writing a data to a queue. We have output binding as a queue. We'll now look more into triggers, the different kinds of triggers and their use cases. First is HTTP trigger. Think of this like an API endpoint. You can build lightweight serverless REST APIs using this trigger. Very useful for code operation and microservices. Second one is timer trigger, perfect for scheduled jobs like cleaning up old files every night or sending reports every Monday. Third one is queue, and fourth is service bus trigger. These are great for communications. You can queue up the tasks and let your function handle them one by one. Now we have blob trigger, runs when a new or updated blob is detected in Azure Blob Storage. Then there are triggers like event grid triggers, Cosmos DB triggers. If you are working with NoSQL and want to trigger logic on data changes, this is the way to go. Useful for syncing analytics or reactive programming. Event grid triggers are runs when event is pushed to an event grid subscription. Then we have signaler triggers, response to signaler messages, and event heap hub trigger, which is runs when events are received in Azure Event Hub, which is another service which reacts on events and specifically used for IoT solutions. Now let's see all of these things in working. I'll be showing you demo of the Azure Functions. Here's our demo function app. Let's understand the structure. First comes is program.cs. With isolated model, Azure introduced this program.cs file. In process, we used to have a startup. I'll be also explaining what is isolated and process model in next video. So program.series is the entry point to our Azure functions, where we can add dependency injection, we can add our services, and it builds function apps. Then we have a local.settings.json, which is used while we are debugging it in local. It has two settings. First one is Azure Web Shop Storage, which is set to development, and then another one is function worker runtime, which is required is .NET isolated. It shows that it's a isolated function. Then we have host.json. It's a global configuration files. We also have one more thing called as functions.json. Function.json works for one single function or specific function. If function.json is about individual behavior, host.json is about the global environment and performance settings. It has properties like logging, version, function timeout. If you are running a batch jobs or heavy background tasks, you will want to increase this, but for short-lived function, keep it tight to reduce cost. Then we have something called as extension bundle, which is also in our host.json. This simplifies messaging extension like Cosmos DB, Service Bus, Event Git. It helps managing this extension. We can also have a queues configuration is this host.json. If a message fails, how many times should Azure try again? That we can add using max DQ count. Also visibility timeout we can add. There are such configuration that is present in this host.json. Function of JSON, as I said, it works with a particular function. It can also have a couple of things like auth level and type of trigger, which is the direction kind of settings. Then we have actual function. Here I have created a function which is a HTTP trigger based function. It takes a request and it deserializes it to the object, which is our user request, and then it writes a message saying hello with whatever the request name passed, and then welcome to Azure. We'll be checking how it works soon. So let's run our Azure function. Okay, our Azure function is started now. Let's go over to the Postman and try to send a request to this function. Let's check out the response. So I have created a simple post request, create user, where I have sent name as Bob. Let's see how it works. As you can see, we are getting a response which has a message in body. It says hello Bob, welcome to Azure function. So that's all for this video. I'll be covering more topics like isolated in process functions, then dependency injection. I'll be going through the configuration of host.json. This will be in our next videos. But meanwhile, do let me know in comments what topics you would like to deep dive into next videos. Don't forget to like, subscribe and share this with your tech buddies. See you in the next videos. Keep building in the cloud. Thank you.